What's up? I'm Vin, and today I want to look at the free response questions from the Geometry Regents January 2020. So let's jump into this. And first up here for question 25, we're going to write a set of 3 congruency statements that would show angle-side angle congruency for these triangles. Now, in order to do this, let's say I pick side QR in the first triangle. Well, notice I went with the second and third letter. So if I highlight the second and third letter in the next letter arrangement, that would correspond to side ML, and these two sides would be the same. But now I need to show angle-side angle congruency. So that would, in the first triangle, I would need to highlight angle R and angle Q. And notice this side QR is between those two angles. But in this triangle, angle R and angle L would be corresponding, and they would be congruent. And we have angle Q, the right angle, would correspond to angle M over here. So now we just have to translate all of this into congruency statements. I would have angle R is congruent to angle L. And then we have QR, so side QR is congruent to side ML. And then last we would have angle Q is congruent to angle M. So here's our set of 3 congruency statements, and this would establish angle-side angle congruency. Question 26, we have this word problem here, and Diego is installing stuff for his birdhouse. And we have the base of the birdhouse over here, 24.5 inches long. And the support beam forms a 38-degree angle with the vertical post. But here's the actual question. Determine and state the approximate length of the support beam X to the nearest inch. So really what we're doing here is just trigonometry. We want to solve for X, and we know the measure of this angle here. Just be mindful that across from 38 degrees, this is the opposite side. Okay, so we know the opposite side. And in this right triangle, what we're looking for here is the hypotenuse, which I'll abbreviate. So we have to know this mnemonic here, SOHCAHTOA, because this is going to help us choose the correct trig function. So we know the opposite side, and we want to find the hypotenuse. So that's going to correspond to the sine function here. So what we have is we're going to have sine of 38 degrees is equal to the ratio of the side opposite, 24.5, we'll just write as 24.5, over the hypotenuse, which is x. And now just cross multiply and do the algebra to solve for x. So I'd have x times sine of 38 degrees equals 1 times 24.5. And now what we're going to do here is just divide both sides by sine 38 and just type the rest in a calculator. So we want to solve for x. The rest is calculator work. X equals. So before we type this in, remember it was sine of 38 degrees, but notice we're in radians. So we're going to go to mode, and we're going to scroll down and switch over from radians to degrees. Just make sure that you do that, because otherwise this could really just ruin your test score. So we have 24.5, and we're dividing by sine of 38 degrees. So now we're good to go here, and let's just bring this back to the main page. So the calculator told us 39.79459.651. But what we need to do here is we need to round to the nearest inch. So if we round to the nearest whole number, notice we have a 7, which is bigger than 5. So we're going to round this to 40 inches. And this is our solution to question 26. So question 27, we have a rectangular tabletop, and we're told the density that this thing is 43 pounds per cubic foot. The next thing we're told is that the length is 8 feet. So we'll just extract that information. The width is 3 feet. And then we have the height is 1 inch. So we have to be careful here. Notice this unit doesn't match. Well, 1 inch is 1/12 of a foot. So now all the units do match. So we're going to use this one instead of that one. And now what we have to do is determine and state the weight of the tabletop in pounds. Well, the thing that always comes to mind with these density questions is that density is equal to mass over volume. So if we're solving for the weight, even though technically in physics mass and weight are not the same thing, we'll just say here that mass is equal to density times volume. So in a way, I think of like we're solving for the mass, but in pounds. So what we have is we're going to multiply the volume, and the volume of a rectangular tabletop we could find by doing the length times width times height. But we're going to do the volume times the density. So now we could just say here the weight, and we'll just write this all out in their language. The weight is equal to, we have the length, which is 8 feet, times the width, which is 3 feet. And then the height, we're going to write it in terms of feet, is 1/12 of a foot, times the density. So the density here, we're saying, is 43 pounds per cubic foot. In cubic feet, we write as feet to the 3rd power. Now, how does this cancel out? Well, just notice feet times feet times feet is cubic feet. So I can just say here 8 times 3 is 24, and 24 times 1 over 12 is 2. So I have 2, and then feet times feet times feet, once again, is cubic feet. And then we have times 43 pounds per cubic feet. And now notice cubic feet over cubic feet cancel, and we're just doing 2 times 43 is 86. So this tabletop is going to weigh 86 pounds. This is our solution to question 27. For question 28, we have to know some tangent secant theorems here. So we have this segment here, CA, this entire thing, is 12.5 units long. CB, this part, is 4.5 units long. And we want to determine and state the length of DA, which is a tangent segment here. So I'm just going to go ahead and put an X over here. But one thing that we have to know for this is we have to know the tangent secant theorem. So what we could say is that CA, the entire secant, times the exterior part, BA, is equal to the tangent segment here from D to A squared. So is equal to DA squared, like this. Now we could put an X here, or we could leave it as DA. Either way, it doesn't matter. So what we have to do, though, is we have to find what is the length of BA. So we know the whole thing is 12.5, and this inside chord is 4.5. So if we subtract here, this is going to tell us that BA is 8 units long. So now we just plug in and solve this out. So we have BA times CA. So CA is 12.5, and we're multiplying this by BA, which is 8 units long, and this is equal to DA squared, like this. So now if we want to solve for DA, just go ahead and take the square root of both sides like this. Okay, and this is going to tell us that DA is equal to, and this is just calculator work, but 12.5 times 8 is 100, and the square root of 100 is 10. So DA is 10 units long. This is our solution to question 28. For question 29, we're constructing a 45-degree angle with the vertex at point M. So what we could do for this, there's a few ways to do it, but one way that'll definitely work is we could construct a perpendicular bisector first. So we set the compass to more than halfway, and now we're going to swing an arc above, and we're going to swing it below like this. Okay, so just make sure you extend the compass to more than halfway, otherwise these arcs are not going to intersect. So now we place the vertex here on point T, and we repeat this process, and we'll just make sure that it's as precise as possible. So here we are at point T, and we swing the arc here. Notice we have a point of intersection, and then we do it down here, and there's our next point of intersection. And now we could just connect these two. So we'll just go ahead and just draw this in. And of course, at the actual Regents, this question is going to be on paper, so you're going to have like an actual compass, but this is the idea that then you would take a ruler and just draw a line connecting those two arcs. So then what you're going to do from here is you're going to move the compass over to point M, because that's where the vertex has to be. And right now we have a 90-degree angle, but we're going to construct an isosceles right triangle. So I'm going to set the compass and measure it here. And just to make sure this is precise, let's just move it in a little bit. And now we're going to draw in an arc just to show that we're measuring this distance. And now what we're going to do is we're going to move the compass over here to the vertex, because once again, we're going to be building a right triangle where both legs are the same length. So if both legs of this right triangle are the same length, then this is going to be an isosceles right triangle, so both angles will be 45 degrees. So now we just have to connect this point here to point M. So we'll just draw this in carefully. Let's connect this point here down to this point here. Question 30, we have 3 intersecting medians, and just know a median goes from the vertex to the midpoint of the opposite side. So that means E, F, and D are all midpoints. And another thing to know about medians is that when they intersect each other, they cut each other into a ratio of 1 to 2. So let's label everything. CE is 5 units long, but if we use that idea that medians cut each other into a ratio of 1 to 2, that means XC is twice as long as CE, so this would be 10 units long. And then we have YF, this whole thing is 21 units long. So if this was, let's say, equal to P, this would be 2 times P, and P plus 2 times P would have to equal 21. And doing a little bit of algebra here tells us P equals 7. So FC would be 7 units long, and CY would be 14 units long. And then we're told here XZ, this entire side is 15 units. So once again, all 3 of these points, FD and E, are midpoints. So we just divide by 2. That tells us these are 7.5 each. So now let's think about what is the question actually asking for. We want the perimeter of CFX. So we want the perimeter of this triangle over here. So we just have to add those numbers together. So we're going to have 7 plus 7.5 plus 10. And just know this is going to give you 14.5. And 14.5 plus 10 is equal to 24.5. So this is the perimeter of triangle CFX. So we want to determine and state the equation of a line perpendicular to this line that passes through the point 512. So in order to write the equation of a perpendicular line, we have to know the slope of that line. So we could solve it for y equals. So we'll just go ahead and take this equation here, 5x minus 4y equals 10. And now to solve for y, what we could do is we could add 4y to both sides. And then next line we'll have 5x equals 4y plus 10. And now we could just subtract 10 on both sides. And then the last bit of algebra to do here, I'm going to rewrite it as 4y equals 5x minus 10. The last bit of algebra is going to be to divide everything by 4. So now what this tells us is that the slope of this line, we're going to have 5/4 x minus 10 over 4. I could just simplify to 5 halves, dividing the top and bottom by 2. But the slope of this line is equal to 5 over 4. Okay, and this comes from the idea that y equals mx plus b. The slope is the coefficient of x when the equation is in the form y equals mx plus b. So if our slope is 5 over 4, the slope of our perpendicular line we could find by taking the negative reciprocal of 5 over 4. So we're going to flip it to 4 over 5. That's the reciprocal part. And the negative reciprocal, or we could say opposite reciprocal, just puts a minus in front. Now, just so you know you did this correctly, if you multiply the old slope by the new one, that product should be equal to -1, which it does. So far this is checking out. Now our point is 512. And then the last part here is knowing the equation y minus y1 equals m times x minus x1. And they didn't tell us which form to write our answer in. So all we have to do is just plug this stuff in. We have y minus 12 equals, the slope we're going to use is the perpendicular slope here because we want the slope, or we want the equation of the perpendicular line. So the perpendicular slope is -4/5, and then we have x minus 5. And we could absolutely stop here. If we had to though, let's say they wanted us to solve for y, then we would just be distributing here, and this would give us -4/5 x plus, and if we just do that on the side, 4/5 times 5, notice 5 over 5 cancels, so we'd have plus 4, y minus 12, and then just add 12 to both sides. And this would give us y equals -4/5 x plus 16. So this is a second way to write our answer out, but once again, we could stop here since they didn't tell us to write it in y equals form. So for this question here, I would just go about finding the length of all 4 sides and showing that they're all equal, and that would prove that this quadrilateral is a rhombus. So notice here, side NA, we could use the distance formula. Or if we don't remember the distance formula, you could always count the rise over run. So we got to go up 1, 2, 3, 4, 5, and we're going over 1, 2, 3, 4, 5. So that means we have to rise 5 and we have to run 5. So that tells us that NA is equal to, and if we do a little Pythagorean theorem on the side, we could say that NA squared is equal to 5 squared plus 5 squared, because notice, once again, we have a right triangle here like this. So that means that NA is equal to the square root of 5 squared plus 5 squared, and this is equal to the square root of 50. And I'm pretty sure we don't have to simplify this, but just in case, if you want to make sure you don't lose any annoying points, call this radical 25 times radical 2, and radical 50 simplifies to 5 square root of 2. And now we could just go ahead and do this for the other ones here. So let's say we target AT next. Notice we got to go down 1, and we'll use a different color. So we're going to go down 1 and over 1, 2, 3, 4, 5, 6, 7. So if we're going down 1 over 7, this right triangle is a way different shape here. So this one has a vertical leg of 1 and a horizontal leg of 7. So that would tell us that AT is equal to, but same idea, AT squared, that's the hypotenuse. AT squared is equal to 1 squared plus 7 squared. So I would just take the square root of this, and that tells us AT is equal to the square root of 1 squared plus 7 squared. But notice, once again, we got the square root of 50, and that's going to give us 5 square root of 2. And now we just have to repeat this for the other sides here. So now we're going to go to TS, and you see TS, this one we're going to go up 1, 2, 3, 4, 5, and we're going over 1, 2, 3, 4, 5. So this is another scenario here where we have the square root of 50, and this is equal to 5 root 2, because we're going, once again, up 5. We'll make that darker, and we're going over 5. And then for NS, the last side, so side NS is another one of those flatter triangles here. So we're going down 1 like this, and we're going over 1, 2, 3, 4, 5, 6, 7. Okay, so this right triangle, we're going down 1 over 7. So this is the same scenario that we had with AT. This is going to be the square root of 1 squared plus 7 squared, which is going to be equal to 50, and this simplifies to 5 root 2. So now to complete this proof, we just have to summarize everything we observed here. All 4 sides of this quadrilateral are equal in measure, so therefore quadrilateral nats is a rhombus. For question 33, there's a lot to read here, but ultimately we want to determine and state the length of a ladder to the nearest tenth of a meter that David needs to buy for his treehouse. Now the ladder in the diagram they zoomed in here is this part that I'm highlighting in green. And notice that the ladder is part of this right triangle that I'm also drawing in green. But in order to find the length of the ladder, we need to focus on this right triangle first in blue, which corresponds to David's eye level in the context of this word problem. So what I would find here is that we know that David is 1.5 meters tall, but there's a few things that we could find based on this. So if we draw this right triangle in blue over here, one thing that's constant about both of these right triangles is David's distance to the actual tree house. This horizontal distance is not changing. So this right triangle in blue, I could go ahead and label this horizontal leg as 1.3 meters because once again, David's head and feet are the same distance away from this vertical part. So we could label this as 1.3 meters. And let's say I call this part here y naught. And we have this angle is 56 degrees. So now if we want to find the length of y naught, think of the mnemonic from before, SOHCAHTOA, that we know the adjacent side to 56 degrees, but we want to find the opposite side. So that's going to correspond to tangent. So we can make the statement here that tangent of 56 degrees is equal to y naught over 1.3. So if we want to solve for y naught is equal to just 1.3 times tangent of 56 degrees. And this we could just type in a calculator, and I'll go ahead and round this. This is going to be 1.927. Okay, so we'll stop it here. At the end, we want to round to the nearest tenth, but I don't recommend rounding to the nearest tenth throughout the question. Round to the nearest tenth at the very end, otherwise that could throw your answer off by a little bit. So now that we know the length of y naught, which is this part, see that's this part over here, that's going to be 1.927. Now we could go ahead and I'll make this a little neater. So we have 1.927. We could go ahead and draw and label the green triangle. So the green triangle here, I'll just draw on the bottom, once again also has a length at the bottom of 1.3 meters. And now we just have to combine what we found over here. So this blue portion is 1.927. So far we have 1.927. But then we would just add that to David's height is 1.5 meters. So we have plus 1.5. And be mindful, once again, this is meters. And ultimately, our goal is to find the length of this hypotenuse, which represents the ladder. So I could put any letter there. Let's say I just put this in as the letter C. So what we have is we would have 1.927 plus 1.5. And if you just add that up, that's going to work out to 3.427. So we could just call this 3.427. If you add those two numbers together. So now we just have to use Pythagorean theorem. So we'd have 3.427 squared plus 1.3 squared is equal to c squared. And if we just punch this part in a calculator, this is not too crazy to type in, so I'll just go ahead and let you do that. This tells us c equals to the nearest tenth of a meter is going to be 3.7 meters like this. Okay, so we could just go ahead and label this. This is the length of the ladder. Okay, here's a nice word problem about chocolate almonds. So we have two containers that hold almonds, and we have the first container, and here's the second container. And the new one is a rectangular prism with a square base, which means we could label the base as, let's say, x. So we're going to label the length and the width both as x, because a square, all sides are equal, so these two sides will be equal. And these two containers are going to have the same amount of almonds, which means the volume of these two are going to be the same. So now we have the height of the new container is 16 centimeters. And what we want to do is determine and state to the nearest tenth of a centimeter the side length of the new container if both containers contain the same amount of almonds. So one thing you have to know here is that the volume of the first one we could find by using the formula pi r squared times h. And the volume of the second one is going to be found using the formula length times width times height. And these two volumes are going to be the same. So we could set them equal to each other. So we're going to have pi times the radius. We just have to be careful. We're told the diameter is 14 centimeters, which means the radius is going to be half of that. So half of 14 centimeters is 7 centimeters. So we're going to have pi times 7 centimeters squared times the height of this one is 18 centimeters. Has to be equal to, we have x times x is x squared, and then we're multiplying by 16 centimeters. Because once again, the volume of the second container, the rectangular prism, we're doing length times width times height. But the length and width are the same because we have a square base. So then here, what we have to do is we're just going to work out, we have on the left side here, if we multiply all of this out, 7 times 7 times 18 times pi, that's just all calculator work. That's going to give you 2770 point, and you'll have 88, and you'll have 472 cubic centimeters. And we'll just stop here. This should be enough because we're going to round to the nearest tenth. But just a little word of advice, don't round to the nearest tenth at this step. Wait to the very, very end to round. And now this equals x squared times 16 centimeters. So now we're just going to divide both sides by 16 centimeters. And what that's going to do is it's going to reduce, well, this side it's going to cancel out completely 16 centimeters. But on this side, centimeters to the third over centimeters to the first is going to reduce this to centimeters squared. So now what we have is that x squared is equal to, and we have 2770 divided by this term here. And this is going to be all calculator work, so I'm just going to leave this as is for now, because this is exactly how I would type this in a calculator, which we'll see in a moment. But we have centimeters squared like this, and now we're going to take the square root of both sides. And see how we want to state the length of the new container. So when we take the square root of centimeters squared, that's going to tell us our answer in just centimeters. And now we're just doing this fraction here, taking the square root of this, and that's going to work out to the nearest tenth. We're going to round this down to 13.2. So 13.2 centimeters is the side length of this new container. So now for the second part of this question, the owner wants to display these chocolate almonds on a shelf, and the dimensions of the shelf, it's 80 centimeters long and 60 centimeters wide. So if we just draw this out here, what I like to visualize is that this is going to be 80 centimeters long and 60 centimeters wide. So the shelf could only hold one layer of new containers. That means we can't stack them on top of each other. And the container is going to sit on its square base. And we need to determine and state the maximum number of new containers the store owner could fit on the shelf. Well, one thing we have to be mindful of is that all of these containers, if we draw them out, are, so now we found the base is 13.2 by 13.2, and the height was 16 centimeters. So the concept is, because this thing is sitting on its square base, that's how we're going to lay these out, is we have to think how many times could we fit 13.2 going this way along the 80 centimeter length. So that we're just going to do 80 divided by 13.2, and 80 divided by 13.2, this is all calculator work, is roughly 6.06. Now this is not rounding to the nearest whole number, this concept. This means that we could fit 6 containers across. So we could do 6 across going this way. But now how far back could we go? Well, every container that we have here is, we could just imagine, also has to go back, but we only have 60 centimeters that we could go back. So we're going to do 60 divided by the length, 13.2. And if we do that division, this is going to work out to 4.5 if we round. But once again, we have to round it down. We could go 4 back. And now the concept is we could do 6 across, 4 back. So that's going to be 6 times 4. So the maximum number of containers the store owner could fit is going to be 24. This is our solution to the second part. All right, so question 35, the final boss, the 6-point triangle proof. So we have all this given information here. And what I like to do first with these questions is I like to label the stuff they give us. So we have angle ABG, that's over here, is congruent to angle CDG, which is over here. And then we're told that AB is congruent to CD. So we can mark these two as the same. And then we're told that CE is congruent to AF. And the goal is to prove that FG, that's this line segment here, is congruent to this line segment here. So what I like to do for questions like this is come up with a strategy. And I think the most common place that students go wrong is that there's so much to do for these questions, they have nowhere to get started. So they wind up leaving this blank, and it's just kind of sad because it's worth so much. So if I want to prove that two line segments, or even if it was proving two angles are the same, the strategy is to show that they are corresponding parts of congruent triangles, because once we know that they're corresponding parts of congruent triangles, we could say they're congruent. And the two triangles that we could show are congruent are the ones I just dotted here. So the strategy is going to be to show that triangle EGB is congruent to triangle FGD. Okay, so that's my focus here, is how do I show these two triangles are the same? Well, one thing I noticed was that the alternate interior angles formed here are congruent. So when you have congruent alternate interior angles, the lines involved here are going to be parallel. So this line AB is parallel to this line CD over here. And when we have one pair of opposite sides of a quadrilateral are congruent and parallel, that means we have a parallelogram here, which tells me then that these two sides are going to be parallel. So sides BC and AD. And now that these lines are parallel, we could say that alternate interior angles formed over here are congruent as well. So this angle is going to be congruent to this angle. And I can already see where this is going. BC is congruent to AD, which means if these two segments are the same, then the differences are going to be congruent as well. So this side BE is congruent to side FD. So far we have these two triangles that we're targeting have one pair of congruent sides, one pair of congruent angles, but now by vertical angles, we could say here that these vertical angles are congruent here at these opposite sides of the intersecting lines. So now I have these two triangles are going to be congruent by angle side. So now that the strategy is mapped out, we could just list all of this. Now the first thing you'll always say here is the given information, but you're not going to get any points for this, but it's very important that you state the obvious because that allows you to write everything that follows. So then here in our sketch here, the first thing that we noticed was that side AB was parallel to side CD. And the reason for this, we said when alternate interior angles formed are congruent, the two lines involved that are cut by the transversal are going to be parallel. Okay, so we're just going to state that formally in statement 2 with this reason. And then once we establish that these lines are parallel, that allows us to say that ABCD, this quadrilateral, is a parallelogram because we have one pair of opposite sides are both congruent and parallel. And now that we have ABCD as a parallelogram, we could move forward here and say that side BC and AD are both congruent and parallel. And this has to do with the idea that opposite sides of a parallelogram are congruent and parallel. Now, once we've talked about these two sides, the next thing we could say is that segment BE, this segment over here, is congruent to segment DF by the subtraction postulate. We could specify the congruent segments that we're subtracting in this part here because this particular statement is a little bit tricky to establish. Notice we established that the entire segment BC and the entire segment AD were congruent in statement 4, and in statement 1 we said that the pieces that we're subtracting, CE and AF, are congruent. And the subtraction postulate says when congruent segments, that's CE and AF, are subtracted from congruent segments, that's BC and AD, the differences BE and DF are also congruent. So that's what we're establishing here in statement 5. Now, what we're going to do from here is we're trying to set up angle side congruency here. So we just have to make a few more congruent statements. We have angle EBG is congruent to angle FDG because alternate interior angles formed are congruent. Notice it's very important that we establish that BC is parallel to AD. Otherwise, we can't say this. So you just have to make sure that you're establishing this. All those small details make a big difference with this last question. So now moving on here, we could say that angle BGE is congruent to angle DGF, and we have vertical angles here are congruent. So now moving on here, we just have a little bit more to say. We could say now that triangle GEB is congruent to triangle GFD, and we have angle side postulate for congruence. So once again, you have to make sure that you make those 3 statements of congruence, and notice statement 5 established the congruent pair of sides. Statement 6 established a pair of congruent angles, and we established the second pair of congruent angles in statement 7. And now that we've established that these two triangles are congruent, we could go ahead and wrap this up. We're going to say here, the last statement, that segment FG is congruent to segment EG and CPCTC.